A lambda function is a simple one-liner hack for writing functions in Python. For example, let's say we wanted to create a function that summed 3 values. We could write sum3 equals lambda x, y, z, semicolon, x plus y plus z. After the lambda, you have your inputs, then you have your semicolon, and after the semicolon, you specify what you want to return. Notice that we don't have return anywhere in this expression. That is because whatever is after the semicolon, it is assumed that you will be returning that. Okay? Now, we could have very well created this function by using the conventional def syntax. We could have wrote def sum3, the inputs, and then return x plus y plus z. But the difference is that the lambda can only be written in one line, whereas with the def syntax, you can write more than one line. Now, the real power of lambda functions is that they can be called as you define them. For example, if we revisit our sum, and let's say we wanted to define it as we are calling it, we could do it like this by using the lambda. We could write print. We keep our lambda expression inside of parentheses, lambda. I will just copy and paste this so I'm save time. Okay, and now I can just specify the inputs like this, 1, 2, 3. With the def syntax, this is not possible because with the def syntax, you have to first define the function. So I first have to define it. Now I can call it. So sum3, and that works just the same. One use case for this is, say we want to pass a function as an argument, and at function call we could create a lambda as the input for the argument. So a good example of this is, say we were to create some function on the fly and we wanted to check the performance or the time it took. Well, we could create a check func time, and then we could pass the lambda as that input of that function. This is how it will look like. So import time, and then we have def check func time, and we have func. This will be the function that we pass, and then we have the arguments. These will be the arguments for that function. Okay, so we have our start time, time, and then we simply execute our function, and then we have our end time. Now, I don't have to specify the end time. What I'll do is I will return the delta, which is the time elapsed. So return time, and then minus the start time. So this will give the delta. So let's say we want to check the speed of a for loop in the minimalist sense, meaning that there weren't really any expressions for it. In that context, how long does a for loop take for a given number of iterations? So we could say check func time, and then we create our lambda. N will be the number of iterations that we wanted, and then I will write a list comprehension. So underscore for underscore in range n, and then for n I will specify 10 million. So 0, 0, 0, and then 0, 0, 0. Okay? Now underscore is, remember I mentioned, is like a filler if you don't care about the item you are getting from your container. In this case, we do not. So running this, we get a little under 1 second. Isn't that quite impressive? Now, if you're following this course in order, you may have not covered list comprehensions. Don't worry too much about that. Basically, they're like a shorter way of condensing a for loop into a list. But we will go more in depth with that later, okay? We can even simplify wrapper functions or decorators. For example, in our previous video on decorators, we had the annotate decorator. So I will copy and bring that here. Now what this decorator did is it took a function and annotated it at its input and then also annotated it at its output. Well, if this expression can be condensed into one line, then ideally we can take this whole inner function and turn it into a lambda. Well, we can do just that. If we take these two print statements, we can turn them into one print statement. So by simply just doing this, take this out, and then I'll have a \n to create a new line, okay? And now I will just turn this into a lambda. This is taking args, so I will have args, and then I have turned it into a lambda. Now if I take all of this, I can simply just take all this out, and now I have return lambda. So I have successfully condensed this whole decorator into this simple two-line function where it returns a lambda for the inner function. And now if I decorate or annotate a sum function, so annotate sum, we can see that the results will be just the same. And indeed they are, okay? Now we can even go further with this logic. We can even create one big line of nested lambdas. So for example, in our decorator video, remember we added another layer to our annotate decorator? So let me bring that here. We added this layer of all caps equals false, where it simply just made this decorator customizable to being all caps or not. Well, we can even take this whole expression, we can turn it into one line of nested lambdas by realizing that there's nothing going on in between these layers. Everything that is going on is in one giant expression underneath annotated, okay? So what I can do is I can just simply turn this into a function, and I have done that. So I'll put it right here. So this is like the condensed version of this, okay? And now what I'll do is I'll write annotate equals lambda, all caps, equals false. So this is the very top layer. And then the next layer is lambda func. This is the second layer. And the final layer is lambda args. And I will return print annotate print func args all caps. Now basically what I've done is I've taken this customizable decorator, which is written like a behemoth, and simplified it into 4 lines by using nested lambdas. Okay, so that's the other power of lambdas. You can just stack them on top of each other. And if I were to, just as in the previous video, annotate a sum function and then annotate a subtract function, whereas the first was all caps and the second was not all caps, then running it, I get the same result. Okay, so all caps and then subtract 10, 3. They're not all caps. Okay? Lastly, there are even special built-in functions where lambdas are very useful to use. One such built-in function is the filter function, where you can filter a container or precisely an iterable based on some logic. In this case, the lambda function is the logic. So for example, let's say we had a list, L equals list from integers 0 to 99, range 100. And let's say we wanted to get the second half of this list. We can use a filter like this, lf equals filter. And now we specify our logic, lambda x semicolon x greater than 49, because the second half is 50 and above. And second, we input our list, okay? So now if I print lf, I get a filter object, but if I convert it into a list, I get the second half, 50 and above. Another such built-in function is the map function, where instead of filtering based on a condition, we will simply just apply the lambda function on each element of the iterable, okay? So let's take our same list. Now I will say lm equals map, and I simply just want to take each element and raise it to itself. So I can write lambda x semicolon x double asterisk x. Remember, the double asterisk is for exponents. Okay? And then I have L. So now if I do for Li and Lm and then print Li, I should get each of the new elements. And as we can see, these are exponentially getting larger and larger.